let's discuss volume and surface area. So the volume of a solid is just a measure of how much three-dimensional space it fills up. So, imagine that you have like some cup and you are filling it up with water. The amount of water that you can fill up in the cup would be like that's its volume. So geometric solids are just like three-dimensional shapes, basically. Like they have their outer faces, and then they can kind of like contain some space within them. So here we have like this rectangular solid. Here we have like a circular cone, and here we have a sphere, for example. The volume of a rectangular solid is just given simply by length times width times height. I guess I used capital letters up here and lowercase letters down here, but you get the gist. Length times width times height is just equal to the volume. This speaks to like a more general formula. So anytime that you have, anytime that you have like a cylinder or a prism where you take some base and then you just kind of like imagine like taking that base and then pulling it straight up and then kind of tracing out some shape. So here, like every like cross section of this cylinder right here is just a circle, or I don't know, it looks kind of like an oval here. But if you're able to measure the area of that base, like if it is like a circle, then like, hey, your area of the base would be pi r squared given by, whatever your radius is. And if you know what the height is, then just multiply the area of the base times the height to get the volume of that solid. That applies over here as well. Here our base is just a, it's supposed to just be like a square right here. It just looks kind of skewed, but imagine that all of these angles, if you were to look at it top down, they are actually like right angles. Like this is supposed to be a rectangular solid. So if your base is just a rectangle with length L and width W, then the area of the base would be length times width, and then you just multiply that by the height to get your volume. Spheres are defined similarly to circles in 2 dimensions. A sphere is just a collection of points in 3-dimensional space, a fixed distance from a center point. Circle is a collection of points in 2-dimensional space that are a fixed distance from a center point. Sphere is literally just the same definition, just you're extending to 3-dimensional space. The volume of a sphere is given by 4/3 pi r cubed. I'm not going to justify that formula. That's just kind of there for you. If you are interested, there are plenty of videos out there on YouTube that justify this, but we won't get into it. Diameter and radius definitions are similar to 2-dimensional as well. Just the maximum distance between 2 points on the sphere gives you your diameter, and the radius would be the distance from the center point to an outer point on the sphere. So if I wanted to find the volume of the following 2 solids, what would I do? So here we have a sphere with radius 6. So the volume would be 4/3 times pi times the radius cubed. So 4/3 pi times 6 cubed. And then our units would be in cubic centimeters. You could go ahead and plug that into a calculator. I'm not going to bother putting it into a calculator. I'm just going to say this would be your exact answer, and then a calculator could give you a decimal answer if you're interested. What about this solid over here? So again, we have like some prism, and we have base. The base of the prism is just some right triangle. It looks like, that is a right triangle. That information just kind of being told to us that it's a right triangle. The base is 3 inches. The the height is 4 inches. And so to get the volume, we could just do the area of the base times the height. The height is just given to us to be 8 inches. And the area of the base, well, it's a triangle, so the area of a triangle is base times height over 2. And then the height is 8. So 4 times 3 over 2, that's equal to 12 over 2, which is equal to 6. And 6 times 8 is 48. And this is measured in cubic inches. If you're kind of curious about how the where the units come from, you know, we're kind of multiplying 3 inches times 4 inches divided by 2 times 8 inches. So we have like, we're multiplying by inches 3 times. That's why it's like cubic inches. Onto surface area. We can measure the area of the faces of a solid and call that the surface area. So here we have this rectangular solid. It has 6 faces. We have this outer face right here. We have this face over here. We have this bottom face. And then we have the 3 faces that are like opposite those. So that one, and then this back one right here. So there are 6 faces. If you were to take a pair of scissors and just kind of cut along some of these edges and then unfold it, you could flatten this out onto a table like so. And you can kind of see like, oh, this is coming from like that top right there. This right here is coming from the bottom. This right here is coming from maybe the front face. Maybe it's coming from the back face, depending on where you cut. These 2 right here are like the 2 sides. And then this would be either the back or the front, depending on what this one was. And so if you were to add up the area of these 6 faces, that would be what we would call the surface area. So anytime that you're measuring the surface area of a solid, you can always just kind of think of it in terms of the area of each face individually. Just so calculate all of those and then add up all of those areas to get your total surface area. So if I were to measure the area of this rectangular solid, let's say that I had length, width, and height. Over here, length, I guess that would be, wait. Okay, so this would be H. This one would be L, and this one would be W, right? Okay. So label that. And then all of these are H. So then if I were to write down, oh, and what is this? This is W. This is W. This is L. Okay, so now if I wanted to write down the area of each of these 6 faces, I can do that. Let's maybe make this a little bit bigger so I have more space to write. This area right here is W times L. This is L times H. This is W times L. This is W times H. W times H. L times H. And then to get your surface area, you just add all of those together. So the surface area is W times H plus W times H. So that's like 2 times WH. And then I have 2LH. And then I have 2WL. And so that would be the surface area of this rectangular solid. So some common surface area formulas. So that is one of the common ones that you'll see, formula for surface area. I think it's probably more valuable to think of it in terms of just like find the area of each of the faces and add them together, as opposed to memorizing a formula. Memorizing the formula is usually not going to be the way to go, although sometimes you kind of have to. Like this right here, a sphere, you can't really like think of the sphere as just like a collection of faces in the same way that you can some rectangular solid. A cube has 6 faces, and each of the faces, the area of each face is just s times s, or s squared. So you have 6 faces, each area is s squared, surface area is 6s squared. Some other, albeit less common but still relevant surface area formulas. The surface area of, so if you take a cylinder, so here we're specifically saying that the base is a circle with radius r, and the cylinder, it's a right cylinder, so it's going like straight up, it's not like going off to the side or anything. This surface area would be 2 pi r squared plus 2 pi r times the height. So this one we can actually kind of think of more intuitively though. So where does the 2 pi r squared come from? Well, it comes from the area of the top and the bottom. The area of the bottom is just pi r squared. The area of the top is pi r squared. So you can think of this as just pi r squared plus pi r squared for the top and the bottom. And then what about like the outer part? So the outer part seems like more confusing, right? But it's actually not too bad. So you could just think of the outer part as, well, take the circumference of that circle. What is the circumference? The circumference is equal to 2 pi times the radius. And if you were to just trace out that circumference all the way down, what do? Well, you're actually just tracing out the entire side of the cylinder. And if you're just tracing out the side of the cylinder, you can really just multiply this circumference times that height h to get the surface area of the outside. If you were to sort of like cut this, so cut it right there and then just unravel the side, you would just literally see a rectangle where the height would be h, that's where you cut it right there. And then what would the base be? Well, the base, when you unravel it, would just be like the circumference of the circle, which would be 2 pi times the radius. And so what would the area of that outside part be after you cut it and unravel it? It's 2 pi r times the height, base times height. All right. Here I have a cone. This is a right cone. So here our area of the base is going to be pi r squared. And what about the area of the rest of the cone? So there is a little bit of, like you can kind of like come up with this part of the formula yourself, and doing a similar like thing as we did over here, where you just kind of cut it and unravel it and then see what you get. You would get like some like fraction of like a circle if you did that. We're not going to bother doing that. I'm just going to kind of tell you it comes out to be just pi r squared plus the area of the outer part of the cone would be pi times radius times the length of this slant. So this slant height L would be in the formula. Whereas like this H, maybe I should have put this in gray actually, because it doesn't really show up in the formula. Like you do have like a height as normal, but it is, to me, somewhat surprising. I guess not that surprising, but it doesn't show up in the formula at all, but the slant height does. All right, here's a question for you. Which of the following units would be used to measure volume, which would be used to measure surface area, and which would be used to measure circumference? So maybe pause and think about it. There will be like multiple answers for some of these, and then I'll, see if you get the same thing as me. All right, so which would be measuring volume? Maybe let's just go through it like one by one and say like, is it measuring volume, surface area, or circumference? All right, feet. Well, feet, this is just a unit of distance, so it doesn't measure volume or surface area. It could measure circumference. I don't know why I said circumference. I probably should have said like perimeter, but whatever. But anything that's like a measure of distance, feet could measure that. So perimeter, circumference, or whatever, it can measure that. Square inches, this is like this is a measure of area or surface area. Cubic yards, this would be a measure of volume. Acres, so this is like a little bit weird because acres is actually a measure of area, right? Like if I have like 10 acres of land, I'm really talking about like how much land area do I have. So acres is a measure of surface area. Gallons, that measures volume. That's like kind of talking about like how much like water can like fill up like a jug or something. So gallons measures volume. Meters measures perimeter or circumference, any sort of length thing. Feet per second, none of these. This is like measuring like distance over time, which doesn't correspond to any of these. And then cups would be used to measure volume, similar to like gallons. Okay. Anytime that you have like units that are like being squared, if it's a unit of distance squared, then this will typically just be used to measure some sort of area. If you have some unit of distance cubed, that would be used to measure volume. But every now and then you'll see things like acres or gallons where it's like, even though it's not being squared, it's still a unit of area. And even though this is not being cubed, it's still a measure of volume, because these are just sort of canonical measures of surface area or volume, just generally speaking. Or this is more area as opposed to surface area, but same principle can still apply. All right, let's finish it out with some examples. Let's find the surface area of the following solids. So I would recommend that you pause and try to figure these out on your own, and then compare answers. So I'm just going to go ahead and do it. So we're going to apply the same principle of just like find the area of each of the faces and then just add it together. So here our surface area is going to be, well, we're going to have two faces with area 3 times 5. We're going to have two faces with area 3 times 7 and two faces with area 3, 5, 3, 7, 5, 7. Okay, 5 times 7. So just making sure that I have all the pairs, 3 times 5, 3 times 7, 5 times 7. To make my computation easier, I could go ahead and factor out a 2 from all of these. You don't have to. You could just multiply everything out. You could be flexible with this. I'm going to multiply everything out just so I can kind of get a final answer here. So 15 plus 21 is 36. 36 plus 35 is 71, and then 2 times 71 is 142. Our units would be cubic inches because our units over here would be inches. So we're doing like inches times inches. Oh, sorry, that's wrong. That would be square inches. Yeah, so we're doing like 2 times 3 times 5. And it's two groups of 3 inches times 5 inches. So the units over here would be square inches. Units over here would be square inches. Units over here would be square inches. You add all those units together and you just get square inches. Okay. Same principle for over here. We just find the surface area of each of the sides here. So this one's like a little bit trickier because this side length up here is not told to you. But if you remember the Pythagorean theorem, which says that a squared plus b squared is equal to c squared, we know that a and b are 3 and 4. So 3 squared plus 4 squared is equal to c squared. This is our c. So this is 9 plus 16, or 25. And so it's taking a square root of both sides, we can get that our value of c is just equal to 5. Okay, cool. Well, let's use that to now find the area of each of these faces. So let's find the area of the triangles first. So there's 2 of the triangles, so our surface area will be 2 times the area of the triangle. And the triangle has area base times height over 2. So 3 times 4 over 2. And we have 2 of them, so we multiply it by 2. Okay, and now we have 1, 2, 3 faces on the outside. All right, so what would those faces... So the height is always going to be 8, right? This face right here is going to have base 3. So 3 times 8, and then we'll have 4 times 8 for this side one, and then 5 times 8 for that back one. So we'll have 3 times 8 for the front one, 4 times 8 for the side one, and 5 times 8 for the back one. I'm going to simplify all this. So here the 2's cancel out, and we're left with just 3 times 4, which is equal to 12. 3 times 8 is equal to 24. 4 times 8 equals 32. 5 times 8 is equal to 40. 12 plus 24 is 36. 32 plus 40 is 72. Add those up, and I get 108. And this would be measured in square inches. Okay, so that's it for that video. Thank you all for listening, and I'll see you in the next one.